Hey there. We're going to talk today about some distance and motion problems. By now you've noticed that I'm just kind of slowing way down to go through these word problems. You need to be able to know those key phrases that are going to help you when you translate, so don't forget about those. Today our objective is I will learn the relationship between distance, rate, and time to solve for missing values. I will build on my knowledge of translating words into mathematical sentences to help me solve applied motion problems. The key phrase for today is distance, rate, and time. Here we go. Distance, rate, and time problems. D always stands for distance traveled. R always stands for rate or speed. You'll see it, key phrases to look for: miles per hour, kilometers per second, feet per minute. There's always a distance per a unit of time. That's your rate, distance per a unit of time. And then, of course, our time. All right? The cool thing about distance, rate, and time is that if you know two of the three values, you can always solve for the third. Oh, hey, there's Javier. All right, so Javier drew this triangle, and D is on top here, right? So distance is equal to, this is an equal sign, rate times time. The cool thing about this triangle is that if you wanted to find rate, it would be distance divided by time. Let me switch my pen here. R is equal to distance divided by time. If you wanted to find time, time would be distance divided by R, or rate. So if you can remember this triangle, it'll help you solve for any of those pieces, whether they ask you to find the distance, what rate the thing was traveling at, or how long it took. All right. If you're looking for D, you're going to be looking for things that say how far. All right. If you're looking for rate, you're going to be asked questions like at what speed did this thing travel, or at what rate was it traveling. And if you're looking for time, it'll say how much time did it take for it to travel, all right? So pay attention to what the question is asking for, right? All right, the speed of sound is 1,088 feet per second at sea level and at 32 degrees. Under these conditions, how far does sound travel in 5 seconds? How far? Let me get my highlighter here. All right, how far? So what are we looking for? How far tells us we're looking for distance. So we're going to be, our variable is going to be D. Doesn't matter what you call it. It might be helpful if you call it D. We're looking for distance. Okay? So that means that somewhere inside the text here, we have to be able to tell the rate at which we were moving, or its speed, and then the length of time, all right? So we're going to use D is equal to R times T, okay? The rate, it says the speed of sound. Anytime you see the word speed, that's a rate. If you're going 60 miles per hour, that's your rate. Your rate is 60 miles per hour. In this case, we're going 1,088 feet per second, all right? So we have 1088, okay? And then we're looking for how long we're traveling at that rate. So times 5 seconds, all right? So how far did we travel? Well, we traveled whatever that number is times 5. 5,440 feet in 5 seconds. That's our distance. D is equal to 5,440 feet. Okay? So the next question says, under these same conditions, so we're still traveling at 1,088 feet per second. All right. How far does sound travel in 1 minute? Okay. How far? So we're looking for D. The rate is 1,088 feet per second. And the time is 1 minute. Well, notice that our rate is in seconds. So how many seconds are in a minute? Well, that's 60. 60 seconds. All I did was convert that into seconds. And then I'm going to apply the same formula. I'm looking for D, so D equals R times T. And I have 1,088 times 60. So I take 1,088 and I multiply it by 60. And I get 65,280 feet in 60 seconds. All right. The winner of the first Indy 500 averaged a speed of 74.59 miles per hour. So that's important information. This is speed, so this is going to be a rate. All right. That's a rate. How long did it take him? How long did it take him? So what are we looking for? We're looking for time. All right. So time is our variable. Time is the variable. That's the thing we don't know. Our speed is 74.59. 74.59 miles per hour. The distance, the Indy 500 is always 500 miles. Okay, so how do we set up our equation to solve? Well, you can look at your triangle, all right? The triangle says DRT, right? So if I want to find time, I have to take time is equal to distance over rate, okay? And you plug in what you know, distance and rate. So time is equal to 500 divided by 74.59. And when you do that, you get 6.7 what? What is time in? In this case, time is in hours, right? T is equal to 6.70 hours. Just like that. Sorry, I'm about to sneeze. All right. At the 2012 Olympics, a record of 2 minutes, you have to know how to read time like this, 2 minutes, 19.59 seconds was set for the women's 200-meter breaststroke. What was Rebecca Soni's speed? Actually, she set this, in 2012. All right. So the thing we have to be careful of is look at our units of time. We're in minutes and seconds. We either need to be all in minutes or all in seconds. And at this point, you get to choose. All right. I'm going to go ahead and convert this into just minutes. All right. So I know that. So I have 2 minutes for sure, and then I have to figure out what 19.59 seconds is out of a minute. So it's 2 plus 19.59 out of 60. All right, and when you do that, you get 2.3265. Okay. So that's my time. I'm going to write it over here. Time is 2.3265 minutes. Okay? My rate, that's what I'm looking for. What is Rebecca Soni's speed? That's rate. Okay, so just let R stand for rate. And the distance, how far did she go? She went 200 meters. Okay, now let's say you're like, oh gosh, do I multiply? Do I divide? What do I do? If the triangle thing doesn't work for you, always remember one form of it, because then you plug in and your equation will tell you what you're solving for and whether you multiply or divide. If you always were to start with distance equals rate times time, okay, we would plug in for D, we would get 200 equals R I don't know, and T is 2.3265. Okay? And then you're just going to take and divide 200 by that number. So you would get R is equal to 85.96 meters per minute. Meters per minute. Sorry, that's like really crammed in there. All right? So if you know your triangle, you could go straight to R equals D divided by T. That's fine too. All right. The next type of problems you're going to be asked to solve in your homework tomorrow are what are called motion problems. In general, you have two vehicles moving in some kind of relationship to each other. So two vehicles will be in motion. Begin each problem by setting up two expressions. All right? Now, this is the way I do it. The book uses this table thing that I don't like, confuses me, so I'm assuming it's going to confuse you. You want to find two expressions, the distance traveled by the faster car and the distance traveled by the slower car. All right? So notice what I have here. Let me get my highlighter. Okay? I just have some symbolism to help me keep things straight. This is the distance of my faster vehicle, all right? D with a little f. The little f means nothing other than it tells me information about my fastest vehicle. It's the rate that my fastest vehicle is going times the time it travels, all right? Then I have the distance of the slower vehicle. Again, the s is nothing more than just a way to identify which one is moving faster, which one is moving slower, identify the two different vehicles in the problem, all right? So then I have the distance traveled by my slower car is going to be its rate of the slower car times the length of time that it's traveling, all right? So here's where the rubber meets the road, okay? You can either have vehicles moving in the same direction, you can have vehicles moving in the opposite direction, or you can have vehicles moving towards each other. All right. So in the course of your reading the text, if you find out that the vehicles are moving, they tell you that the vehicles are moving in the same direction at different rates, then you're going to take the difference. All right. If the vehicles are moving in the same direction, you'll take the difference of their distances traveled. All right. Let's say the vehicles are moving in opposite directions, all right? Then, in opposite directions at different rates, you're going to add the two distances together, because if you subtract off an opposite, then it actually becomes plus. So you're going to use the sum of the two distances traveled. That's going to be the distance apart if they're moving in opposite direction. You've got one, say, moving to the left 4 units. You've got one moving to the right 3 units. So the distance between them is getting bigger, all right? And it's getting bigger by adding those two things together. The other case that you can have are vehicles moving towards each other. And when you're moving towards each other, then you want to add those distances together as well, all right? So when they're moving in the same direction, you're going to take the difference of the distance traveled. That's going to be the distance apart, okay? If they're moving in the opposite direction from each other, you're going to add. And if they're moving towards you, you're going to add to find that distance apart. It'll be like, how far apart will they be? Or at what point in time will they be this far apart? Okay, those are the types of questions that we're going to be asked to solve. Okay, just don't let the words or symbols freak you out. Look back to those slides as we go through this. Look back to those slides, that slide that tells you either add or subtract, okay? And just take a phrase at a time, okay? Remember those symbols, while it looks complicated, DF and RF and TF, that's just a way to identify. That's it. That's all it is just a way to identify the two different vehicles. One's going to be moving faster than the other, okay? So let's try this. I have a lot of this worked out for you. So let's just read through it and let's see where all these pieces come from. All right. 2 cars leave St. Louis at the same time, and they both travel west. They both travel west. So would these cars be traveling in the same direction or in opposite directions? Well, hopefully you said the same direction because they're both traveling west on Interstate 70. They're like headed to Mizzou. All right. All right, so make a note that this is traveling in the same direction. So I'm going to write same above here. Can you read that, hopefully? Same, okay? Now it says one vehicle, one, is traveling at a speed of 65 miles per hour, okay? And the other at 75 miles per hour. So which one is going faster? Well, the one driving 75 miles per hour, right? How long, so we're looking for a length of time, how long until they're 25 miles apart? How long? What are we looking for? We're looking for time. How long? We're looking for time, okay? It's important that you be able to read the question and figure out which part of those 3 things they're asking you to find, okay? All right, now set up the 2 expressions, all right? Set up the distance of the fastest car is equal to its rate times the time. The time we don't know, but we know the fastest car is going 75 miles per hour, right? So the distance traveled by the fastest car is 75t, okay? The distance of the slower car is 65t because its rate is 65 miles per hour. You do recognize that 65 mph is a rate and a rate. Okay, this is the rate of slower. This is the rate of faster. Okay? Now, these guys, we've already said, are moving in the same direction. They're moving in the same direction. So our formula slide tells us if our 2 vehicles are moving in the same direction, to find their distance apart, we have to subtract them, right? So we take the distance traveled for the fastest car minus the distance traveled for the slowest car, and then we set it equal to how far apart they are. They are 25 miles. We want to know how long to go 25 miles apart. All right? Now we're going to plug in the expressions here for DF and DS. All right? The distance traveled of my faster car, that's 75t, right? The distance traveled for my slower car is 65t. And then the difference of those 2 things has to equal 25 miles. Now I just solve for t. 75t minus 65t is 10t, and 10t has to equal 25. Okay? So then you just take 10t and divide both sides by 10. And you get 10 is equal to 2.5. So when you state your answer, you say in 2.5 hours, they will be 25 miles apart. In 2.5 hours, they will be 25 miles apart. All right? All right. Two planes leave Kansas City at noon, flying in opposite directions. Flying in opposite directions. If one flies at 410 miles per hour, that's a rate. There's a rate. Can you hear Mr. Westrich snoring? Makes me mad. If one flies at 410 miles per hour and the other flies 120 miles per hour faster, then how long until they are 3,290 miles apart? Okay? So, how do we define this one here, the faster one? All right? This one is flying 410, so that's going to be my slower one, right? So the distance traveled of my slower is 410 times t. The distance of my faster, it's 120 miles per hour faster than 410. So what is that? That's going to be 530 t. All right? They're moving in opposite directions. So now I just add them together and set them equal to the miles that we want to discover how long it takes them to get this far apart. Okay? So then I do 530 t. Why? Because that's just what I defined the distance of my fastest vehicle. All right? In this case, the vehicle being a plane. Plus 410 t. Oops, I'm going to erase here for a second. Oops. I have, my faster is 530 t plus 410 t is equal to 3290. Okay? So now I'm just going to add those together, and I get 940 t is equal to 3,290 miles. And then I'm just going to divide. All right. So t is equal to 3.5 hours. So in 3.5 hours, how do I know my time is in hours? Because it tells me I'm in hours, because I'm in miles per hours. The planes will be 3,290 miles apart. Okay? Because they're moving in opposite directions. Okay? All right? We have two planes that leave St. Louis at the same time, flying in opposite directions. There's the word opposite. Okay, so underline it or highlight it. One heads to Chicago, the other heads to Dallas. So if you picture a map, you got one headed north and one headed south. Because of the jet stream, the plane to Chicago is traveling 50 miles per hour faster than the other. So what that's saying is that it has wind helping push it along. Okay? In 30 minutes, the planes are 275 miles apart, how fast is each plane traveling? What am I looking for? I'm looking for the rate. I'm looking for the rate. How fast? Okay? How fast? So that means I'm looking for rate. I start in the same spot, that the distance of my faster plane is going to be the rate of my faster plane times the time. All right? Now, be careful because the rate is going to be in miles per hour and the time that they give us is 30 minutes. So I have to make sure I convert that into hours. 30 minutes is the same as 1/2 hour. So my T is going to be 1/2 hour. Okay? So again, I'm going to set up two expressions. The distance traveled of my faster has to be the rate of it times the time. Now let's read to figure out what the rate is. The plane traveling to Chicago is traveling 50 miles per hour faster than the other being the slower. All right? So we have to take R and add 50 miles per hour to it. So the rate of my faster one, my faster plane, is going to be R plus 50. I don't know what the rate is. I just know that I'm going 50 miles per hour faster. Okay? The rate of my slower vehicle is just going to be R. It's whatever that rate is, because when I figure that out, then I have to add 50 to it to find the rate of my faster plane. All right? So the distance traveled of my slower vehicle is going to be its rate times its time. Okay? So the time is exactly the same, 1/2 hour. All right? Okay, so now we're going to plug in those two expressions. All right? We have 1/2 R plus 50, and we have 1/2 R. So the distance traveled of my faster is equal to, I'm just going to move my 1/2 out in front, just to keep it the way we're used to seeing it. 1/2 times R plus 50. Plus the distance of my slower vehicle, which is 1/2 times R, has to equal 275. Okay? Because that's how far they're apart in 30 minutes or 1/2 hour. So now I just solve for R. I use distribution, and I collect like terms, and I solve for R. So I'm going to distribute first. So I have 1/2 R plus half of 50 is 25. That's a 2. Plus another half of R equals 275. I'm going to combine like things, 1/2 R and 1/2 R. Here's a half of an R, and here's a half of an R. So that gives me 1 R, or just R, plus 25 is equal to 275. Okay? Then I'm going to subtract 25, and I'm going to get R is equal to 250. R is going to be in miles per hour. Miles per hour. Okay? Because that's how we measure that kind of stuff. That's the normal thing. We wouldn't do it in miles per minute. We would do it in miles per hour. All right? So if that's the rate of my slower vehicle plane, what is the rate of my faster plane? Well, the other one is going to be R plus 50. Or it's going to be going 300 miles per hour. Okay? So the faster is 300. And that one's going to Chicago. The slower is 250. Just like that. Faster plane is 300 miles per hour and the slower plane is 250. All right, let's try it again because the more you do these, the easier they will feel. Okay, 2 buses leave the terminal traveling in opposite directions. Opposite directions. Opposite directions. So this means we're going to be adding our distances together. Okay, one has an average speed of 10 miles an hour more than the other. An average speed of 10 miles an hour more than the other. All right, so that means our rate, one will be R and one will be R plus 10. Okay, 12 minutes, which is 1/5 of an hour. I got that by taking 12 and dividing it by 60. That's 1/5 of an hour. 12 minutes into the trip, they were 12 miles apart. Find their speeds. Find their speeds. What are we looking for? We're looking for rate. But again, regardless of what we're looking for, we're going to start at this very same spot. Okay? The distance of the fast car, or bus in this case, all right, is going to be its rate times its time. Okay? So, the rate of the faster one is R plus 10, all right, times 1/5 of an hour. Okay? The rate of the slower car is going to be R times 1/5 of an hour. When we add their distances together, they need to be 12 miles apart. Right? Now we're going to substitute in our expressions. All right? I have 1/5. Again, I'm going to put my 1/5 up in front. R plus 10 is equal, plus, might as well erase. Plus 1/5 R has to equal 12 miles. Now I'm going to distribute and I get 1/5 R plus 10/5, which is 2, plus 1/5 R has to equal 12. So 2/5 of R plus 2 has to equal 12. Subtract the 2. So 2/5 of R has to equal 10. Now, how you proceed from here, you have choices. I like to do it in one step. Many of you like to do it in two. If you want to do it in two, you're going to, I'm going to move over here. You're going to multiply both sides by 5. So you would have 5 times 2/5 R equals 10 times 5. These are going to cancel, so you get 2R is equal to 50. R is equal to 25. Okay? Because you would divide both sides by 2. Sorry, I skipped that step. All right? If you wanted to do it all in one step, you would multiply by 5 over 2, the reciprocal of this number. 5 over 2. All right? And you would get the same thing. So the slower vehicle is going to be 25 miles per hour, and the faster vehicle is going to be 35 because it's going to be 10 miles per hour more. It's going to be the faster one. Okay? All right. I think this is the last one. There are 5,980 miles between Atlanta and Palm Beach, Florida. John leaves Atlanta at an average speed of 68 miles per hour, headed towards Palm Beach. Kate leaves Palm Beach at the same time, averaging 62 miles per hour, headed towards Atlanta. How long will it take them to meet? How long? What are we looking for? How long? We are looking for time. How long says time. All right? We're going to start with the same two expressions. The distance traveled of my faster vehicle is going to be its rate times its time. Okay? So we're going to have, I'm going to put it back in my pen. My faster vehicle is 68 miles per hour. So I have 68 T. All right, my slower vehicle is going at 62 miles per hour. 62 miles per hour times its time. Okay. How long will it take them to cover this 598? This is the miles that they have to cover. So we're going to set the sum of those things equal to 598. Okay? We're going to add those two things together. So we have 68T plus 62T has to equal 598 miles. And then when I add those together, I get 130T equals 598. And I'm going to do that division. Is 4.6 hours. T is equal to 4.6 hours. 4.6 hours. So roughly 4.5 hours to get there. Who's going to travel more miles? Well, that's going to be John, because he's going faster. All right. So if we state the answer, it will take 4.6 hours to meet. Okay. All right. Why don't you try this one? Hit pause. I haven't done this the whole thing. Hit pause. Try this one. See if you can get it and come back. Okay. Welcome back. St. Louis and Seattle are 2,084 miles apart. You're going to use this number. A small plane leaves Seattle, traveling toward St. Louis at 115 miles per hour. Another plane leaves St. Louis at the same time, headed towards Seattle, traveling 92 miles per hour. How long until they meet? These are traveling toward each other. They're traveling toward each other. Okay. Okay, they're not going very fast, all right, for planes. So what are we looking for? How long until they meet? So we're looking for time, all right? We're looking for time. All right, the distance traveled of my faster vehicle is its rate times its time, all right? So we have the rate of my faster vehicle is 115 times the time. 115T, that's its distance, is 115T. The distance traveled of my slower vehicle is 92 miles per hour times time, so it's 92T times time. All right? When I add these two distances traveled together, they have to add up to 2,084 miles. Okay? So now I have 115T plus 92T equals 2084. All right, what's 115 plus 92? 207. So that's 207. T is equal to 2084. So I take 2084 and I divide it by 207. And you get 10.1 hours. T is equal to 10 point, you get 0.67. I'm just going to go up to 10.1 hours. Okay. So they will meet in 10 hours. These have to be pretty tiny planes. These are going to be like Cessnas and those little bitty planes. Okay? All right. So we're going to do 2 days of these. Notice how few problems I have given you. All right? These should all start looking the same if you'd like to take a peek at them before class. I don't want you to do the tables. If any of them have tables, I want you to ignore it. I want you to kind of treat it more like an equation, like what we're doing. All right? All right? Thanks for listening, and I will see you tomorrow. Bye now.